Recording in progress.
Uh, Gokul, am I audible?
Audible, sir.
Just wait for another 5 minutes if someone will come. So are you able to see my screen?
Yes, sir.
Okay. Okay, I'll start teaching. So, have you solved the week 4 assignment and all? Google?
Yes, sir.
Okay. So I'll just do some theory and try to revise, and then we can solve some previous year assignment question. Okay. So I'll proceed. So you have any doubts in the lecture or anything you can tell me?
No, sir.
Okay. So let us consider an RL circuit. Okay. So we have this. Okay, we have voltage source and the switch is closed at t equal to 0. We have a resistor as well as we have an inductor. Okay. So this is this is a voltage source, which is AC voltage source. Which will give a voltage of Vs is equal to Vm into sine of omega t. Okay. This is the voltage which the voltage source is generating. Okay, it is a function of time. So it is like a sinusoidal excitation to this RL circuit. Okay. So now at also this is the inductor current. Since RL, all the voltage sources are in series, the current flow should be the same through the resistor as well as through the inductor. Now at t equal to 0 minus, okay, at t equal to 0 minus, the current through the inductor was 0. Okay, that is before the switch was closed, the current to the inductor was 0. Why will it be 0? Because current cannot flow. When the switch is open, current cannot flow, and because for a current to flow, there should be a path. There should be a closed path. But as the switch is open, there's no closed path. Hence, the current to the inductor before the switch is closed is 0. Okay. And also we know that for an inductor, the current through it after will not change instantaneously. So after we close the switch also, the current to the inductor will still remain 0. At that instant, the current to the inductor will remain 0. Okay. So any doubts still here?
No, sir.
Okay. So now, when the switch t is equal to 0, time t equal to 0 is closed, and then it will result in a differential equation. Vm sine omega t minus I into R minus L into di by dt is equal to 0. Okay. Or we can write it as L into di by dt plus I into R is equal to Vm into sine of omega t. Okay. So now, when this differential equation is solved, okay, we have studied last week how to solve these differential equations. Also, we have also considered if there was a sinusoidal excitation. Also, we have considered like the sinusoidal forcing function if it was there. So the solution of this differential equation is given by this. It is actually equal to Vm upon square root of R square plus omega square L square sine theta into e raised to minus RT upon L plus Vm upon square root of R square plus omega square L square into sine of omega t minus theta. Okay. So this is the equation. And this is the equation which we get by solving this linear differential equation and by setting the initial condition of current to be 0. Okay. we will get this equation. So now if you look into this equation, there are two parts. And one more thing to notice, this this is in ampere, this is in voltage. So this must have the dimension of ohm. Okay, so this is like the impedance of the circuit. Like in an AC circuit, the impedance is R plus J omega L. That is the impedance Z in phasor. Z is R plus J omega L. Now, because now the magnitude of this impedance Z is equal to square root upon R square plus omega square L square. Okay, so this is the magnitude of the impedance. So that's why this has a dimension of current. Okay, that's how we verify that the equation which we got is correct. Equation which we have been given is correct. So now let us, this has two terms. One is this term and another is this term. So at time t equal to 0, okay, let us consider at time t equal to 0. I at 0. Okay. This will have, what is e raised to minus RT upon L at t equal to 0? What will this be? E raised to minus RT upon L at time t equal to 0. Any idea, Gokul?
No, sir.
Okay. So this will be e raised to, at t equal to 0, it will be e raised to minus 0. Or just e raised to 0. And anything raised to 0 is 1. Okay. So that's why this will be Vm upon square root of R square plus omega square L square sine theta. Okay. This is replaced by 1 at time t equal to 0. Similarly, this will be Vm upon square root of R square plus omega square L square into, now sine of, at time t equal to 0, sine omega t will be 0 and it will be sine omega t minus theta. So that will be of the form, okay, it will be of the form sine of minus theta. Okay, so that's why I of 0 is equal to Vm upon square root of R square plus omega square L square into sine theta, and we know sine of minus theta is minus sine theta. So it will be minus sine theta. That's why this will come out to have the value of 0. So thus in this equation we have proved that at time t equal to 0 the instant, the current through the inductor is 0, and that satisfies the initial thing which we said over here, that IL0 minus equal to 0 equal to IL0 plus. Okay. Now we will consider a case when t is equal to infinity. Let us substitute t is equal to infinity. Now when we substitute t equal to infinity, we get I of t is equal to Vm square root of R square plus omega square L square sine of theta e raised to minus R infinity upon L plus Vm square root of R square plus omega square L square into sine of omega into infinity minus 0 minus theta. Okay. So now e raised to minus infinity, this e raised to minus R upon L into infinity, like anything we multiply by infinity or like R and L, they do not take value 0. So when we multiply anything by value infinity, it becomes infinity. So that's why this can be written as e raised to minus infinity. So that can be written as 1 upon e raised to infinity. Now e raised to infinity, anything raised, when you raise it to infinity, it is infinity. So it becomes equal to 1 upon infinity. And 1 upon infinity is equal to 0. Okay, so does this make sense? Okay, so that's how we have proved that this will be 0. So 0 into this will be 0. That's why I of t will be equal to 0 plus Vm upon square root of r square plus omega square L square into sine of omega t minus theta, where t tends to infinity. So now, what we have observed is in this circuit, this first term, becomes zero at steady state, whereas this term still remains in the circuit. This term still remains in the analysis which we have observed. That's why in steady state we can write I of t is equal to Vm upon square root of r square plus omega square L square into sine of omega t minus theta. Okay, so this is the steady state current. This is the steady state inductor current. Okay, any doubts still here?
No, sir.
Fine. Now let us draw the graph of this. We draw the graph. Yeah. Just bear with me. This is the input voltage Vs. Okay, and the current has two parts, two components. One is this. One is a decaying component which is coming like this, which is decaying like this, and the other is the component which is lagging. It is lagging. Okay, this component is lagging the waveform. Okay, this is actually very bad. Lagging. In actual reality, one component of the current will be decaying to zero like this, exponentially it will be decaying, whereas the other component will start like this. It will go like this, like this, like this, it will be going. Okay. So that is the other component of the current. I of t, and this is time t. So at time t equal to 0, this is, suppose this is plus 5, this will be equal to minus 5. Okay. That's why the actual current at time t equal to 0 will be 0. It will be here somewhere. Okay, and then the current will have sort of like this curve. Will go, will be a bit up and come down. Okay. So now this is the curve of the current which we have seen for a series RL circuit. And so that's why we have found out that when there's a RL circuit or any circuit which is excited by AC source, and since there are energy storing elements, etc., there will be some sort of transient. Okay, that is this AC transient. This is the component of AC transient. Okay, which will go to 0 as time tends to infinity, and this is the steady state current. Okay, this is the how the steady state current is in the circuit. Okay, so this is there. So any doubts still here, Deepak Kumar or Gokul?
Sir, I have joined late, so can you summarize this question again?
No, we have there's a RL circuit over here. Okay, and there's a AC voltage source. Vm sine omega t. Okay, so at time
Yes, sir.
t equal to 0, I close the switch. Okay, like since the switch was open, the current to the inductor was 0 before the switch was closed, and after the switch is closed, also immediately the current will be 0 because we know that the current to an inductor does not change instantaneously. Then we apply KVL for this RL circuit, and we get this differential equation. And then the solution of this differential equation is given like this. It is of this form. I of t is equal to Vm upon square root of r square plus omega square L square sine theta e raised to minus RT upon L plus Vm upon square root of r square plus omega square L square into sine of omega t minus theta. Okay. So this is the solution of the inductor current. Now, this is e raised to minus RT upon L, which is there. That will decay to 0 as time tends to infinity. When time becomes infinite, this will be 0. So this part will not be there in the current. But this component of current will still remain, and this is known as a steady state current. Okay. And also we proved at time t equal to 0, what will happen? Time t equal to 0, the current is 0. And as time tends to infinity, this will decay to 0 and only this will remain in the circuit. Okay. Vm upon square root of r square plus omega square L square sine omega t minus theta remains in the circuit. That's what also we have graphically also have drawn that. Okay. So now,
Yes, sir.
yeah. So now I will proceed. Now in this RL circuit, in an inductive circuit, the current leads or lags.
Legs.
Lags, right? So even in this circuit, the current actually is lagging the voltage. So now let us draw a phasor diagram. Okay. So now sometimes what happens is we do not want to know about this transient part. This transient part we know it will die to 0. And in steady state, we want to know what will be the value of current or voltage, etc. So for that, we use a concept known as phasor analysis. In phasor analysis, we will neglect this transient component of current, transient component of anything. We will neglect that part. We will only consider the steady state analysis of that. And this phasor concept is used for studying the steady state response of a system, as well as it happens only for one particular frequency. When the frequency is fixed, then this phasor analysis concept comes into picture. Okay. So now here the frequency is fixed. The frequency depends on the supply frequency, and we will see. We will assume the supply vector to be like this. This is a supply phasor. Okay, and we know that a current lags. So that's why the inductor current will lag it by an angle theta. Okay, so it will lag by an angle theta. And phasor means it is not just a constant vector value. Okay, it is something which keeps on changing. That is, it keeps on rotating. It keeps on rotating in the counter clockwise direction. That is in this direction at a speed omega, at an angular speed of omega. Okay, so that is what is known as a phasor. And this inductor current also is not just fixed at a position. It will also keep rotating at the same speed, angular speed of omega, but it will have a constant lag of theta degrees with respect to this supply voltage. Okay. Okay. Any doubts, Deepak or Gokul?
No, sir.
Okay. So now we write this phasor. So it is actually like it will be rotating in a circle. Inductor current will rotate in the circle, and the supply voltage will rotate in this circle, and they will always maintain a phase difference of theta. So when we draw their response, this is the steady state response which I am planning to draw. Okay. So will be look like this. Okay. So this gap is actually theta. That is the phase lag. So this is actually the voltage Vs and this is the current IL. Okay. So in time, it is constantly changing. Inductor current is changing, but we represent it as a fixed value. So this Vs is the reference phasor, and this IL's phase is with respect to an angle theta, that is the phase difference. Okay. So just basically what you must remember is the phasor is actually just a rotating vector. It's like a rotating vector concept. Okay? And the like now this Vs is rotating in this radius, in this circumference. So at this position, its projection is 0. That means at this instant, at this position, the voltage has value 0. But in case it moved to be over here, then the projected value, let's see, projected value will be this much. Okay, Vm. But at this instant, it will be projected to value 0. If it's over here, the projected value will be this much. That will be the instantaneous value of the voltage. If this Vs vector was over here somewhere, then the instantaneous value will be somewhere around here. Okay, so that's how the actual instantaneous value, it will vary like this. It will go up, it will go down like that. That is represented over here. Okay, so it starts at 0, increases, reaches maximum amplitude, again starts decreasing, goes to 0, then further starts decreasing, goes to minus Vm, then again starts increases, goes to 0. Okay, so this is the concept of a phasor, and that is used to represent the steady state AC quantity that greatly simplifies circuit analysis, AC circuit analysis, and that is only applicable when there's a single frequency in the circuit. So, any doubts?
Sir, now how to write the value of Vm? The
How to write?
मतलब,
Bolo?
sir, how to write expression of V voltage?
Sorry.
How to write expression of voltage at steady state in this phasor from
Okay.
this phasor?
Okay. So in this phasor, this is the x-axis. Okay. This is the x-axis. So we will write expression of Vs is equal to Vm into sine of omega t. Okay. This expression, it is rotating at a speed of omega, and it is changing with time. So when time is 0, it is at this instant and its value is 0. Okay. When time
Okay,
reaches
sir.
over here, that is omega t into something comes to be pi by 2, its value will be Vm. So that's how Vs is written like that. Vs is written Vm into sine omega t. Now IL is lagging it. Okay. IL is lagging it, and it is given by Vm, square root of r square plus omega square L square into sine of omega t minus theta. Okay. So this part is the magnitude of the current. Okay, this is the amplitude of the current phasor, and this is the phase lag. Okay, phase lag, theta is the phase lag, and that theta is given by tan inverse of omega L upon R. Okay. Hmm?
Yes, sir.
Okay.
Sir, in case of capacitor, what will be the impedance?
In case of capacitor, it will be 1 by omega c, no? Instead of omega L, it will be 1 by omega c. That's all.
1 by omega c.
Yeah.
Okay, sir.
Hmm. Okay, so this is for a phasor. Okay. And we must always remember that these phasors always rotate in the counterclockwise direction. Okay, that's why we have represented over here that it is rotating in this direction. Okay, so the phasors are rotating in the counterclockwise direction.
Yes, sir.
So we consider phasor initials, amplitude initial frequency. Now we will consider power in AC circuits. Okay, we will consider instantaneous power in AC circuits. So we will consider this. Now, we will consider the same circuit. Vs R L. Okay, this is the current I L. So now Vs is given by some sort of V max into sine of omega t, and IL is given by I max into sine of omega t minus theta. Okay, so this is the expression of Vs and IL.
Yes,
And
sir.
this,
Sir,
huh?
sir, I is equal to Vm by root R square plus omega square L square.
Yeah, that's correct. So I max is actually just this. I max is actually V max upon square root of R square plus omega square L square. Okay.
Yes, sir. Fine.
Yeah. No consequence here. So now we will try to make it better. Yeah. So the power, instantaneous power is actually IL of t into Vs of t. Okay, this is the instantaneous power. This is the expression for the instantaneous power in the circuit. So we will substitute the value of Vs and IL. We get it to be V max into sine of omega t into I max into sine of omega t minus theta. Okay, theta is lagging. Okay. Now, one more thing to keep in mind is in most practical circuits, like your normal house appliances like fans or fridge or various appliances, it is mostly inductive. So rarely you will find a circuit which is capacitive in nature. Okay. So that's why we have considered in our analysis a RL circuit. Okay. We have considered that. So the current is lagging by an angle theta. Okay. Now we will try to simplify this to try to get more insight into this. So this we will write it as V max into I max. Okay. We take the amplitudes together and this we write it as sine of omega t into sine of omega t minus theta. So now can you tell me what is the expansion of sine A into sine B? What is the expansion of sine A into sine B?
cos A minus B plus नहीं हाँ cos A minus B minus cos A plus B.
और क्या रहेगा?
By 2, sir.
Yes, it will be divided by 2. 1 by 2, 1 by 2. Okay. So we will apply this formula over here. So we will get it to be equal to V max into I max upon 2 into cos, this is A and this is B. So cos of A minus B will be equal to cos of theta minus cos of A plus B will be equal to 2 omega t minus theta. Okay. Any doubts in this?
No, sir.
So this is one way we can write this equation, but there is a better way in which we can get more understanding. So what is the full expansion of sine A minus B? Sine of A minus B, what is the expansion of that?
Sin A cos B minus cos A sin B.
Sine A cos B minus cos A into sine B, right? So we
Yes,
will
sir.
apply that over here. Okay, so this is sine A minus B ka type. So we will write it as, we will write it as V max into I max into sine of omega t. Now we will expand this. Okay, sine omega t minus theta. We will write it as sine of omega t into cos theta minus cos of omega t into sine of theta. Okay. So this we will further write it as V max into I max into sine square omega t into cos theta and minus V max into I max into sine of omega t into cos of omega t into sine theta. Okay.
But sir, there is no sin A minus B.
This is not sine A minus B, sine of A minus B. This come when I expand this, I will get the expansion of this. Okay, I will get the expansion of this. It comes out to be this. ये सही है ना?
Okay. Yes, sir. Yes, sir.
हाँ. Then I multiply it by sine omega t. By V max, I max sine omega t, I'll multiply these two terms and I will get it in this form. Okay?
Yes, sir.
Yeah. So then sine square of theta. Here actually lots of trigonometry is required. So what is the expansion of sine square of theta? We can write it as what?
1 minus 2 cos theta.
No, it will be 1 minus cos 2 theta.
Yes, sir. Yes, sir. 1 minus cos 2
1,
theta.
2. Okay. Similarly, sine theta into cos theta will actually be written as sine 2 theta upon 2. Okay.
Yes, sir.
So what will we write it as? P of t is actually equal to V max into I max into cos theta. So the sine square omega t, I will replace it by 1 minus cos 2 omega t upon 2. So it will be written as 1 minus cos of 2 omega t upon 2. Then minus V max I max sine theta into 8 minutes into sine of 2 omega t upon 2. Okay. So the equation comes to be in this format. Alright. So there's one simplification which is used. V max into I max upon 2 is there. I want to write it in a different way. What is the RMS value of a AC signal?
VAM by root 2.
Vm by root 2. That is Vm is V max.
Yes, sir. Vmax.
Okay. So V max into I max upon 2. I will write it down as VRMS. No, let me write it down. Let me write it like this. V max upon root 2 into I max upon root 2. Okay.
Yes, sir.
So this I will write it down as V max upon root 2 is VRMS and I max upon root 2 is IRMS. Okay. So this V max into I max upon 2, I will write it down as VRMS into IRMS. All right.
Yes, sir.
So P of t, we get it to be equal to VRMS into IRMS into cos theta into 1 minus cos of 2 omega t minus VRMS into IRMS into sine theta into sine of 2 omega t. Okay. The meeting will end. I'll start a new meeting again. Okay. Just hold on. Okay. So I'll proceed. So my screen is visible, right?
Yes, sir.
Okay. So this is the equation for the instantaneous power. So it consists of two terms. There's this term and there is another term. Okay. So now we will analyze both these terms one at a time. So let us draw this. Yeah. Will be of this form. Okay. Like this, like this, and this. So that's 0. We'll go like this. So this middle value is VRMS into IRMS into
Cos theta.
this is the middle value or mean value, and it will go be oscillating between this value. Okay, so this will actually be equal to 2 VRMS IRMS cos theta. So it will vary from 0 to 2 VRMS IRMS cos theta, but it will never become less than 0. It will never become negative. Okay, this will never become negative. Okay, so this is like known as the active component of power. Okay, so the first term is known as the active component of power, and and if we consider the average power, the value of the average power is equal to VRMS into IRMS into cos theta. All right?
Yes, sir.
Yeah. Now we will consider the second component, that is Vmax. Sorry, VRMS IRMS sin theta into sine of 2 omega t. We will draw that graph. That graph,
Reactive power.
yeah, that is the reactive power. That is drawn like this. This going like this, like this, like this. Yep, it should have. So this is the reactive power, and its amplitude will be given by VRMS IRMS sine theta. Okay, this will be equal to minus VRMS IRMS into sine theta, and this is the time axis. Okay, so this is known as the reactive power. Like this is the reactive power, and the peak value of this reactive power is VRMS IRMS sine theta. So this reactive power is like a power oscillating between the source and the load. Okay, and the average value of the reactive power is 0. Okay, so any doubts in this?
Yes, sir. Why we don't want this power?
Like when this power is there, what happens is this power cannot be used by the load. Okay,
Yes, sir.
like to do the actual proper work which the load has to do, this reactive power is not needed. Although some reactive power is required for setting up magnetic flux and all, etc., those stuff is there. But what happens is when there's reactive power in the circuit, then the amount of current flowing in the circuit will increase. And when the amount of current flowing through the circuit increases, then there are more losses and all that. So that's why it is preferred to decrease the reactive power which is flowing in the circuit, in the power system and all that stuff. It is very advanced concept and all. It's not like reactive power is bad. Some amount of reactive power is necessary to set up, the flux in the transformer or flux in the induction motor, etc. That time you need reactive power. Reactive power will be there, but it will be lossy in the cables and other stuff. So that's why they have these sort of power factor correction circuits and all that stuff. So they will try to reduce the reactive power which is being used. Okay.
Okay, sir. And sir, what is the concept behind apparent power?
So apparent power is like the combination of the active power and reactive power. So the apparent power will give you it shows you the magnitude of the current which is actually flowing. Okay. So when you draw the power triangle, now let us draw the power triangle. Okay. This is the active power P. This is the reactive power Q. And this is the apparent power S. Okay.
Okay,
And
this is
what is it?
this triangle like this impedance triangle, right?
Yeah, it is similar to impedance triangle. Okay.
Yes.
First, they are just
Yes.
like, it's like just multiplication of voltage and current and something like that stuff. So it will be similar. It has to be similar. Okay. So we would prefer that there's an angle theta. Okay. This angle theta will increase as Q increases. And it is generally preferred that this theta should be equal to 0, but it is not always possible. Okay. And this
Yes, sir.
apparent power is given by S is equal to V into I star. I star is the complement or the conjugate,
Conjugate current.
conjugate of the current. So let us consider, if we consider a capacitive circuit. In the capacitive circuit, let us consider V to be equal to V RMS angle 0. Okay. This is the phasor representing the voltage. The phasor representing the current in the capacitive circuit. Capacitive circuit has resistor, capacitor, etc. The current will be of the form I equal to I RMS angle theta, positive theta. Why? Because in the capacitive circuit, the current leads the voltage. Okay.
Yes,
Any
sir.
doubts here?
Yes,
No.
sir.
Chat out.
No, sir, nothing.
That's why the S will be equal to given by V RMS into I RMS angle theta and iska conjugate. Okay. So that will be
Okay.
equal to V RMS into I RMS into angle minus theta. Alright. So
Okay, sir.
angle minus theta can be written as cos theta minus j
Minus
sine theta.
theta.
Alright. That's why S will be equal to VRMS into IRMS into cos theta minus j sine theta. So S is equal to VRMS IRMS cos theta minus j into VRMS IRMS sine theta. So S will be equal to P minus J Q. Alright?
Yes, sir.
Yeah. So this is for the concept of reactive power and all. Yeah. And the phasor can be represented in three types, in three forms. Okay, one is the rectangular form. In that, it will be written as this A plus BJ. Okay, in phasor analysis, we use the operator J. J operator actually is like it will bring a 90-degree phase shift. Okay, J operator is like bringing a 90-degree phase shift. This J is somewhat different from the complex number I. Okay. So like
Yes,
see,
sir.
let us consider a capacitor. If you can, okay, I'll tell that later. Then it can also be written in the polar form. Polar form is of this form. It will be written as R into cos theta plus J into sine theta. Okay, this is the polar form. As well as there's something known as the exponential form. Exponential. I'm sorry for the bad handwriting. And that it will be written as R into e raised to j theta. It will be written in this form. So this phasor can be represented in various forms. And in the normal thing which we use this form. We use it to be V into angle of theta. And the angle of theta actually represents e raised to j theta. So, any doubts in this?
Sir, how to represent exponential form?
Yeah. This is cos theta plus j sin theta. Okay. Cos theta
Okay.
plus j sin theta can be written in the form of e raised to j theta. R into it will be
Okay,
written.
sir.
That is by De Moivre's theorem and all, which that you have studied in maths, or you should be studying it in maths.
Yeah.
Yeah. Right. So this is just some complex set of maths, and we've done some power, apparent power, reactive power, all this stuff. Is phasor concept of phasor outer rotating vector. It is applicable for only a single frequency. AC transient also is there. Now phasor analysis is used when we are just concerned about the steady state behavior of an AC circuit. So the AC circuit is basically a sinusoidal excitation is applied for a one particular frequency. Now this angle theta is like, so there's a concept of power factor. The power factor is given by cos theta. Cos theta. That is given by P upon S. If we ignore this, okay. So based on a triangle, cos theta is P upon S. Okay. So that is given over here, and that will be used. That is known as a power factor of the circuit. And now we will proceed to solving sums, actual sums, where we hope to use part of the theory which we have learned. Right? So let us consider this sum, where this circuit is given over here. All right.
Sir, I think.
So you guys can see the circuit, right? So now tell me what will be the impedance of the inductor XL. What will be the impedance of the inductor?
L omega, sir.
And
L
Omega.
omega.
you're forgetting something.
Sir, J omega L.
Yeah, J omega L. J is very important. So XL is equal to J into omega L. Okay. So what will be the value over here?
Sir, omega is equal to 200 and L is equal to 40 millihenry.
Okay. So you multiply and tell me what's the answer.
Sir, J8.
XL is equal to 8 into J. Similarly, what is the impedance of the capacitor?
1 by j omega c.
Okay. So what is that?
C is what?
You didn't calculate till now.
Eight, sir.
8.
Minus 8J, sir.
Yes.
Minus J8.
Yeah. Will be minus 8J. Alright. So now, is phasor analysis applicable to this circuit?
No, sir.
Why not?
XL is equal to XC, same, sir. So, resonance takes place, sir.
So, what is the main criteria for AC for phasor analysis?
Sir,
Tell us.
sir, I don't know.
You don't know.
Yes, sir.
So,
Due to this, I got 0 marks in this question.
oh, okay. So now, see, phasor analysis is applicable when there's a single frequency. And here there's a single frequency. So we can apply phasor analysis. So now phasor analysis is for the steady state behavior of this system. You're right that there is resonance occurring, and we will solve the circuit considering resonance to happen. Okay. Now we will consider the effective impedance of L and C together. Okay. Let us consider impedance of L and C. So Z, considering L and C, is actually what? It is XL parallel to XC. Okay. That is equal to J8 into minus 8J upon J8 minus 8J. So what is the value of impedance?
Infinite.
So value of impedance is infinite. All right.
Yes, sir.
So if the value of impedance is infinite, then that would mean the current, this current from the source will not go over here. This current should be equal to 0.
Yes,
Why?
sir. Yes, sir.
Because this provides infinite impedance. The combination of the inductor and capacitor provides infinite impedance. All right.
Yes.
And this is
Yes,
occurring
sir.
specifically at this frequency 200 radians per second. And that is the resonant frequency of this LC tank, this LC circuit. That is the resonant frequency. All right.
Resonance frequency.
Resonant frequency.
Oh, resonant. In resonant frequency, the voltage will be decreased.
Voltage
Right?
will be?
Voltage will start decrease from its initial value. No.
No, there's different. There's series resonances, there are parallel resonances, there are different resonances are there. So this is parallel
Yes, sir.
resonance concept. Okay.
Yes, sir.
In series resonance, there is voltage. What happens is the current is maximum.
Yes,
And they
sir.
will
Or voltage start decrease from its initial value.
there will be constant voltage magnification across LNC. And in parallel resonance, there's concept of current magnifying across flowing through LNC. Okay. We'll see, we'll just solve this. We'll not get into that. All right. So that means the current will not flow through LNC. That means the current from here, it will just flow through the 70 ohm resistor and through the 30 ohm resistor. All right. So we will try to find the value of current, this current I, value of this current I. Okay. You must remember this current I is equal to IR because this ILC is equal to 0. All right. So this current I, which is equal to IR, is equal to 50 angle 45 divided by 30 plus 70. That is 50 angle 45 divided by 100. That is equal to 0.5 angle 45 ampere. So this is the current IR. Current IR is equal to 0.5 angle 45 ampere. Any doubts in this?
No, sir.
No doubt. Oh, okay. So the question is asking, we want to find the current to the capacitor IC. So now what we will do is, the voltage over here, we will assume at this node there's a voltage V. So this voltage V we will find out using we will find out this voltage V using this actually there's a drop across this 30 ohm resistor. V is actually just a drop across this 30 ohm resistor. So this V is actually equal to IR into 30. That is equal to 0.5 angle 45 into 30. That is equal to 15 angle 45 volt. Okay. This is the voltage V at this point. Any doubts in that?
No, sir.
All right. Now we want to find the current through the capacitor. See, the current ILC coming out from here and going into these two nodes is equal to 0. That does not mean that there is no current flowing across here and no current flowing across here. So we will do the analysis and we will show you that if the current is flowing in this direction here, current will be flowing in the opposite direction over here. So the current will only flow like this. So actually what happens in this case is the current is just flowing like this. But the current flowing out here and inside here is actually 0. Alright? So we will draw. So the current IC is equal to V upon XC, that is 15 angle 45 divided by minus 8J. What is this equal to? Do the calculation and tell me.
One point 875.
And the angle?
Angle is 135.
Yeah, correct. Okay. So this is IC. So IC is 1.875 and angle is 135. Right? Similarly, IL is V upon XL, that is 15 angle 45 divided by 8J, that is equal to what? What will be the angle?
$45.
How much?
45.
How?
Sir, minus 45.
Yeah, minus 45. Because there's a J down, right? J is there. This we can also write like this. It will be plus 45 divided by 1 angle 90. So it is actually equal to 1.875 angle 45 minus 90. That's why it is equal to 1.875 angle minus 45. Right? So any doubts in this?
No, sir.
Okay. Then they are telling us to find the active power supplied by the source and the reactive power supplied by the source. Right? So first, before that, what we will do is we will draw the phasor diagram. Okay. They told us that the voltage is 50 angle 45 over here. So it is at an angle of 45 degrees. Let us assume this is 0. So this is like this. This is voltage source 50 at an angle of 45. This is the voltage V at the node, which is a 15 angle 45. This is the current IR, which is equal to 0.5 at an angle of 45. Okay. Now, the voltage across the inductor lags, and that too by 90 degree. So that will be equal to 1.875 angle minus 45. This is equal to IL, and IC leads the voltage across it. That's why IC is equal to 1.875 angle 125. So IC and IL are opposite in phase and they are of equal magnitude, and hence they effectively cancel out each other. Right?
But sir, they have a different angle.
They are 180 degree apart. No, 180 matlab ulta opposite hai.
Yes, sir. Yes, sir.
Yeah. So they cancel out each other.
Yes, sir. Yes, sir. Got it.
Mm.
135, 55, right?
Yeah, 135. Okay.
Yes, sir.
So now we will have to find the active power delivered supplied by the source. So this is the source, and the current IR is equal to 0.5 angle 45. Okay, so we are given the voltage across the source is 50 angle 45 volt. Current is 0.5 angle 45. So ampere. So what is the phase difference between these two? What is the phase difference?
0.
Yeah, so that's why theta is equal to 0.
It
So
means cos theta will be 1.
yeah, so the active power, average active power is Vrms, Irms, cos theta. So it is 50 into 0.5 into cos of 0. That is equal to what?
2.5.
2.5.
No,
Wow.
no. 25.
Ah, all right. 25 watt.
Yes, sir.
25 watt.
Yes, sir. 25 watt.
25
Watt.
watts. Watts.
Watt.
That's right. That's a unit. Okay. You must remember that when we write in phasor form, we usually write the RMS value. Okay, this is 50. So this is the RMS value. Okay. Over here, they are giving the RMS value. They are not giving the peak value. So the peak value will be equal to how much?
VP by root 2.
VRMS is V peak by root 2. So V peak is what?
V peak is what? Maximum voltage or current.
That's why V peak will be equal to yes, VRMS into root 2 is equal to V peak, right?
Yes, sir.
Yeah, so it is max peak is 15 to root 2. Alright.
Yeah, yeah.
So now we got active power to be 25 watt. Let us find the reactive power. Q is VRMS into IRMS into sine theta. So that is
It will be 0.
it will be 0. Alright. 0 watt. What is
Watts.
0 watts?
No, no, no. A volt ampere reactive.
Volt ampere reactive. Alright. That's the way you must remember. Ah, okay.
Sir, I think you are very tired now.
What?
You are very tired now.
Yeah, it's a busy day, na, that's right. So your college is over.
Yes, sir. I start again.
What do you mean start again?
It means my college has been started again.
Okay, this is okay. You are studying where? You told something I forgot again. Indore.
Sir, what?
You're studying Indore, right?
Yes, sir.
Achha.
Sir, now I am in fourth sem.
Oh. Which department?
Electrical
Okay,
engineering.
okay. Then do you have to take this NPTEL course or what? It's compulsory
Yes, sir.
from college side.
No,
Then
from self.
oh, very good, very dedicated person. Nice. Okay, so let's continue. So this is the next question. So just read the question and just tell me how will you proceed to solve this.
By superposition theorem.
Oh, acha, very smart person. Why will we
No,
apply superposition? Why can't we apply phasor analysis?
Phasor.
Phasor analysis. Why can't we do that?
Sir, because there is a two sources, I think, multiple sources.
No, if there are two sources also, we can apply phasor analysis. It doesn't matter.
Then why, sir? Why don't?
No, I'm asking you. Tell me the answer.
Sir, I have not concept regarding this.
Acha. So see the sources carefully. Tell what type of sources they are.
Sinusoidal.
That we know. What else?
Sir, sinusoidal sources are there, and they have a different omega, angular frequency.
Yeah, different omega. So what happens if they have different omega?
Sir, the rotation of current and voltage are different. I think speed are different.
Yeah. So because there are sources with different frequencies, that's why we cannot apply uh, this phasor concept. Okay. That's why
Yes,
we
sir.
cannot directly use nodal analysis or mesh analysis to solve this circuit. It is not allowed. And you know why it is like that? Because let us consider the impedance XL. Okay. XL is 14 into 10 to the power minus 3 into omega. Okay. Now, when we consider this frequency, omega will be 300. When we consider this current source, omega is 600. So the
Yes,
impedance
sir.
will keep changing depending on the frequency.
Yes,
And
sir.
to consider that effect, we have to, we have to analyze the circuit individually for each source, and so we apply superposition theorem. Okay.
Sir, sir, we cannot apply here nodal and mesh also, right?
Yeah, we cannot apply because the sources have different frequencies.
Okay, sir.
Okay. Similarly, this will be j omega, and xc will be equal to 1 upon j 4 into 10 to the power minus 3 omega. Right? So now we will consider only the voltage source to be there. So in superposition, what happens to the current source?
Open circuited.
Okay. So it become What will be the impedance of the inductor? Hmm?
1.2. J
1.2.
1.2. J
How?
1.2.
Kaisa.
Oh,
क्या चमका?
okay, sir. Give me 2 minutes.
Yeah, given 2 minutes. ले लो.
Sir, where are you from?
I'm from Mumbai.
Mumbai.
हाँ.
Okay.
So Gokul, did you find the answer? The impedance of the inductor.
No, sir.
Why not?
Please give some time, sir.
Should keep calculator with you.
Z will be 3.37 J.
What Z?
Z means equivalent impedance. Z is equal to 3.
I didn't ask that. I asked just the impedance of the inductor. एक impedance. इसका impedance कितना है? What is the impedance of the inductor?
J 4.2.
4.2, sir.
Yes.
Sir,
Yeah.
what is your gauge score, sir?
My gate score. I didn't know. Okay, it is 667.
Okay, sir.
Okay. So now we will continue. So what will be the this J will be 4.2 4.2. Okay. Similarly, what will be the impedance of the capacitor?
Minus J 0.8.
Okay, 0.8333. Those are also you cannot ignore. Okay. That's why
Yes.
the voltage VC now we have to find. Okay. Now we can do phasor analysis considering in this circuit because there's only a single voltage source with a single frequency. So this VC will be equal to 20 into this is like a voltage divider. So 20 into minus J 0.8333 divided by J 4.2 minus J 0.8333. Okay. So what will this be?
Sir, 20 sine 300 T, right?
Huh?
Sir, VC is equal to 20 sin 300t multiply by
No, no. Yes, yes, that is there. But now let us ignore that. Let us ignore the sign term because we are applying phasor concept. Okay, we are applying phasor concept, and
Okay,
we are
sir.
trying to solve the value of VC. Then we will apply that when we. This is the VC bar. Okay, this is VC bar. VC bar is the VC phasor. Then we will, when we want to write in time domain, we'll input. But first you solve this and tell me how much. How long it's taking to solve this?
Sir, 5, sir, minus 5.
Okay. Actual value is minus 4.95. So,
Yes, sir.
4.95, approximately 5, sir.
yeah. So this is the phasor value, that is minus 4.95. Okay. So this means now we write it in polar form. VC bar is equal to 4.95 angle of minus 180. Any doubts in this?
Sir, how to write angle of minus 180?
This is minus. Okay. So 1 angle minus 180 is equal to cos of minus 180
Minus.
plus j of sine of minus 180. Okay. So cos of minus 180 is equal to minus 1 and sine of 180 is 0. Let's say minus 1, we can write it as equal to 1 angle minus 180.
Yes, sir.
Okay. This is how the phasor concept helps. So what this means is supply was actually 20 in with respect to 0. Okay. And this VC bar is actually equal to 4.95 in this direction. Okay, so it's actually 4.95 at an angle of 180. Okay, the angle is 180. Does this make sense? Hmm? Hello.
Okay, sir. Okay, sir.
No, if you have any doubts, just let me know. This is why these sessions are there.
No, sir, no doubt.
Okay, so we'll proceed, okay? That means now when we write it in time domain, it will be equal to 4.95 sine of 300t minus 180. Okay? So that when we write it in terms of cos, we will get it to be VC equal to 4.95 into cos of 300t. Okay. See, minus 180 or plus 180 is the same. We can write it as 4.95 angle minus 180, or we can write it as 4.95 angle plus 180 also. Okay, it doesn't make any difference. What that means is plus 180 means you're going from here to here in this direction. Minus 180 means you're going in this direction, but effectively it is just the same position. Okay, so we write it in terms of plus 180. Okay, so that's why this will be 4.95 sine 300t plus 180, and then it will be written as 4.95 cos 300t plus 90. Okay, any doubts in this? This by simple trigonometric expressions which we have. So that's why over here for this network analysis, you must brush up your trigonometry formulas and everything, because they are very necessary. Right?
Yes, sir.
Okay. So we got VC of t. VC of t we have got. Okay. Now we will apply to this one when this voltage source is replaced by a short circuit. And then we will apply this current source. So the circuit will become like this. It will be inductor, resistor, no, inductor and a capacitor. Inductor, capacitor, the short circuit. This is an unknown value of resistor, and this is a current source, which is given by 2. Okay, and frequency is 600. So this is 2 cos 600 t. So what will be the value of this impedance across the inductor? Okay, that was actually here. Okay, 14 millihenry. Can you calculate what will be XL? Hmm?
Yeah, 22.4. J 22.4.
Why you guys are making so many mistakes? 14 into 10 to the power minus 3 into 600. How much is that?
8.4, sir. J 8.4.
Yeah, J 8.4. So this will be J 8.4, and the capacitor will be minus J into 4 millihenry. So it will be 4 into 10 to the power minus 3 into 600. It will be 1 upon 4 into 10 to the power minus 3 into 600. That comes out to be minus J
0416.
0.41667. Okay, that is the value. Okay, so now we will find the effective impedance Z. Okay, the effective impedance is J 8.4 into minus J 0.41667 divided by J 8.4 minus J 0.41667. What is the value be of this? Deepak, you're solving or what? You're seeing TV.
What?
You're solving or you're seeing TV?
Sir, I don't get it.
Are you solving this or are you seeing
No,
some TV or movie or something?
sir, I am solving this.
अच्छा अच्छा तो जल्दी करो. Deepak, did you get the answer? Or Gokul, did you get the answer?
Wait, sir. I am solving, sir. Wait, sir.
Please your speed, yeah.
Sir, Z equal to minus J 3.5.
How did you get such a wrong value? Yeah. No, no, no. It is not that. No. You have to do change the calculator to phasor format, vector thing, and then solve. You guys know, right, how to solve. This
Yes,
is
sir.
J 8.4 into J minus 0.41667 divided by J 8.4 minus J 0.41667. So when I do what I will do is
Sir,
I will,
minus 0.4384, sir.
yeah, yeah, correct. So when I normally will solve this in my calculator, what I will do is First, I will solve the denominator, J8.4 minus J0.41667. I solve it, then I take it, I invert it, and then I will multiply it by J8.4 and minus J0.41667. So I first do the addition, subtraction, all that nonsense first, and then I will do multiplication and division. All right? That's the method I use, and it has worked for me till now. Okay, it's up to you if you want to use that. Now we want to find the voltage. Okay, VC. So this current will flow through this impedance Z. So that's why the VC is actually equal to I into Z. Okay, that is 2 at an angle 0 into 0.43841 at an angle of minus 90. J gives an angle of 90 and minus J gives an angle of minus 90. So the VC effectively becomes equal to 0.87682 at an angle of minus 90. When we write it in time domain, we get it as VC of t is 0.87682 into cos of 600t minus 90. This we can write it as 0.87682 0.87682 into sine of 600t. So, any doubts in this?
No, sir.
No, sir.
Okay, congratulations. Very nice. No doubts. Good. Yeah. Smart people. So we had to write in this form and we wrote it in this form. All right. So even though we couldn't use phasor analysis for this circuit in the full form, when we divided it into each and every individual source, we were able to apply the phasor concept and get the response of the system. All right. Now we will solve this question. So, what do you think of this question? Can we solve it easily?
Yes, sir.
So, is phasor analysis valid, applicable in this question?
Yes,
So
sir.
KCL. KCL.
You can do that. I'm just asking, can I apply phasor analysis in this circuit?
Yes, sir.
Okay, why?
Because the frequency are same.
Where is the frequency written? They've never written anywhere that the frequency. What is the frequency?
It means frequency will be same because they not written.
Yeah. Okay. Yeah, correct. Okay. So it is not specified, so we assume that the frequency are the same. And we do not need the value of the frequency because the impedance values are given. 50 ohm minus J50. J50 is already given, so we don't need the value of the frequency. Now we will apply KCL and we will assume this node to be some voltage Vx. Okay, so this is Vx. So when we apply KCL at the node Vx, we get 50 angle node Vx, right? So it will be Vx minus 50 angle 120 divided by 50 plus Vx minus 50 at an angle of minus 120 divided by minus 50J plus Vx minus 50 at an angle 0 divided by J50. This is equal to 0. Alright? Any doubts in this?
No, sir.
So we'll take Vx common. So it will be Vx into 1 upon 50 plus 1 upon minus J50 plus 1 upon J50 is equal to 50 at an angle 120 divided by 50 plus 50 at an angle of minus 120 divided by minus 50J plus 50 at an angle 0 divided by J into 50. Right?
Yes, sir.
So now we had solved the first sum. In the first sum, what we solved, when the impedances are equal over here, like in such a case, it will become 0. Okay, that we can also
It will
show.
cancel.
Sorry?
Sir, it will cancel to each other.
Yeah,
Minus J50.
they cancel each other. So it effectively becomes Vx upon 50 is equal to, now this 50 and 50 cancel out each other. So it becomes 1 upon 120 minus this 50 and 50 cancel out each other. 1 at an angle of minus 120 upon J, 50 and 50 cancel each other, plus 1 at an angle of 0 upon J. Alright? So when we further simplify it,
Yes, sir.
we will get it to be of this form. 1 at an angle of 120 minus plus 1 at an angle of minus 30 plus 1 at an angle of minus 90. So, were you guys able to understand how this came?
Yes, sir.
How? बोलो कैसा आया?
Because 1 by J is equal to minus 90, angle minus 90.
हाँ, वो समझा. This बीच वाला कैसा है?
बीच वाला कौन सा?
ये वाला -1 angle minus 120 by J. How did it come to be of this form? 1 angle minus 30.
सर J ऊपर जाएगा तो माइनस J होगा.
हाँ.
तो minus J is equal to minus 90 and minus 20 minus 90 will be 210. सर आपने ए वाला साइन भी तो चेंज कर दिया ना.
अच्छा.
हाँ हाँ sir, minus 120 plus 90 will be minus 30 because there is a present already minus, so minus J or minus will become plus J.
Okay, correct. All right.
And plus J will be 9.
Huh?
And plus J will be 90, so so minus 120 plus 90 is equal to minus 30.
Okay, very good. So we will get Vx is equal to, it will come down to be 36.6025 at an angle of minus 60 volt. Okay, this is Vx. Any doubts still here?
No, sir.
So I1 is equal to 50 angle 120 minus Vx upon 50. So that's how we calculate it. We get I1 is equal to.
Sir, I have a doubt.
Yes, tell me.
Sir, in case of plus complex plus number, then what will be the angle? In divide we are we are subtract to each other angle,
Huh.
and multiplication in multiplication we add to each other,
Yes, correct.
and
Then-
in case of plus,
Okay, assume. Okay, I'll tell you. Okay, suppose it is like this. There is one number. Suppose it is 2 angle 30 plus 3 angle 45. Okay, you are asking like this question, right?
yes sir.
So 2 angle 30, you will write it in the form. You have a calculator. So 2 angle 30 can be written as root 3 plus I. Let me just show. 2 angle 30 is written as root 3 plus j. Okay. 3 angle 45 is written as 3 angle 45 is written as 3 upon root 2 plus j into 3 upon root 2. Does this make sense? Huh?
3 it means 3 plus 3 j upon root 2.
3 upon root 2 plus j into 3 upon root 2.
Yes sir.
So when we add these, what happens is the real part and the complex part get added. Become 3 plus 3. Sorry. So 2 angle 30. This is wrong. This will be 2 angle 30 plus 3 angle 45 will be equal to root 3 plus 3 upon root 2 plus j into 1 plus 3 upon root 2. Okay, so the real part gets added, the complex part gets added, and this is effectively the new number, new complex number, new complex
Okay.
phasor. Okay? Yeah.
Okay sir, it means we can directly calculate it like divide and multiplication.
Yes. So I1 will be given by 50 angle 120 minus Vx upon 50. Okay. So when we substitute the value of Vx, we will get it to be of the form 1.732 angle 120 ampere. Okay. Similarly, I2 is equal to 50 angle minus 120 minus Vx upon minus 50J. And when we solve it, we will get it to be 0.89657 angle minus 75. Similarly, I3 is equal to 50 at an angle 0 minus Vx upon 50J. And when we solve it, we'll get it 0.89657 angle minus 45. All right?
Yes sir. Get it?
Yeah. What do you need?
But what?
Okay. Any doubt?
No sir.
Okay. Great.
Sir, I have a doubt. When we convert sine to cos and cos to sine, I am getting confusing in this.
Confusion in this. Okay.
Yes sir. In conversion of sine and cos.
Okay.
Sir, I have a one doubt.
Tell.
And like we have a value sine omega t minus 90.
Huh.
So then what will be the answer in terms of cos?
Sine omega t minus 90. No, it will be cos theta, right?
Will be cos theta directly.
Cos omega t. Cos omega t.
Oh, cos omega t. But formula is that sine 90 minus theta is equal to cos theta, right?
Huh.
So here is a minus 90, omega t minus 90. So what?
Okay. Wait a minute. Maybe I'm wrong. Wait, can you just tell me what's the formula? Sine of
Sir, we know formula is generally sine 90 minus theta cos 90 minus theta sine 90 plus theta. But I have a different problem, sine omega t minus 90.
sine omega t minus 90. Na? So this you write it as minus sine into 90 minus omega t. Okay. So that way
Okay.
will be minus cos omega t then. Minus cos omega t.
Okay, it means we can uh, it means माइनस साइन को निकाल सकते हैं ब्रैकेट से बाहर.
हाँ देखो क्या होता है कि साइन ऑफ माइनस थीटा इज इक्वल टू
माइनस साइन थीटा.
हाँ माइनस साइन थीटा ये होता है ठीक है.
हाँ सर.
पर और ये भी होता है cos ऑफ माइनस थीटा इज इक्वल टू cos ऑफ थीटा.
यस सर. इट
ये
विल.
हाँ. So like this sort of small tricks you have to use to get it.
Okay sir, go. Thank you sir for telling that.
Yeah. You just have to play around with the formulas to get what you want. See, and also one more thing. If it is minus sine omega t, you can write it as sine of omega t plus 180. Simple.
Plus 180.
Yeah. Minus sign means there's a phase shift of 180. That you should show it over here. That way.
Sir, yes sir. Minus sign means phase shift is 180 degree.
Phase shift of 180 degree. Similarly, minus cos omega t means cos of omega t plus 180.
Yes sir, I got it.
Yeah. Okay. And you know this formula, na? Like all silver teacups. Here everything is positive. Here only sine is positive. Here only tan is positive. Here cos is positive. Do you know that?
Yes sir.
Yeah.
Yes sir. I know that.
Yeah. So all those things you must consider to get the correct thing.
Yes sir.
Yeah. Then Gokul, you don't have any doubts?
No, sir.
Oh. Okay. So currently what week you guys are studying right now?
What sir?
So currently which week you guys are studying?
Currently which?
Which week of NPTEL lecture are you guys studying?
Sir, week number 5.
Week number 5 you are studying, and the week number 5 assignment you will submit this Wednesday.
Yes sir, we will submit assignment number of week number 5 this Wednesday, but some lecture are remains in week 5 because of college has started.
Oh, okay. You haven't seen it. Oh, okay. All that mutual inductance, self-inductance, all that stuff, no?
Yes sir, yes sir. Only one lecture are remaining in week 5.
Okay. Well, your college was closed till now. What happened? Why your college had so many holidays?
Sir, because my fourth semester is very short because the third semester will go to very long time.
Acha, why is your college like that?
More than 6 months.
Yeah.
Sir, can you give me your contact number? I want to connect with you.
No, I cannot give you my contact number.
Sir, why?
Yeah.
Sir,
Sir, mail
sir,
ID give, sir. Mail ID.
Mail ID I can give. Mail ID.
okay. Sir, I cannot call you. Just I will do message.
No. All that I can do. Yeah. So this is my mail ID. Okay. This is fine. So you guys have noted it down?
Yes, sir.
Yeah. And any other questions, queries, doubts, problems?
Not now.
Not now. Once you start seeing the lectures, we'll get the doubts.
Yes, sir.
Yeah. It always happens in that. So next week we have to do this one, no? We'll be doing self and mutual inductance as well as solution of linear differential equations. So such things we'll be going through next week. Okay.
Okay,
We'll
sir.
just have a basic revision and we'll be going through it. So you guys are free to join every day, every week at 6 p.m. on Wednesday. We have this doubt clearing session. And these videos get uploaded on YouTube also. The links, I think they will be sharing with you, right? You get the links, now.
Yes, sir.
Okay. How do you get those links? From where?
Sir, I don't get the link.
No, Gopal is saying there's a link for the uploaded video.
Sir, in portal there upload, sir.
Okay. They after how many days do they upload it actually?
Sir, I don't know, sir, but
What? It gets uploaded.
These videos are available on YouTube.
Yeah. These videos are made available on YouTube actually. So
Okay.
that's there. Yeah.
But I saw only Professor Tapas Vatcharya, sir, on YouTube.
No, he's saying on the NPTEL portal also they upload these videos and there's a place from where you can see these old doubt clearing sessions.
Sit. Okay, sir.
Okay. Yeah. So then any other doubt, any other problem? No?
No, sir.
Okay. Then we'll end this meeting, all right? Yeah.
Okay, sir.
Okay.
Bye.
thank you, sir.
Thank you. Chalo. Bye. Good night.